Hi, so in this video I will talk about light and I will start with the first demo. So we start with the old-fashioned way and just a match. And so where does this light come from? So it's basically just hot air and burning wood. And so the hot part is really this sort of a white light, and that's where the combustion is the strongest, while the red part is a little lower temperature and it's a slightly different chemical composition. The blue is also a different chemical potential, and that's why it creates a slightly different color. The white part, so the main part of the flame, is really a mix of gases from the cellulose, which is burning the wood, and also hot air, and that excites these molecules, which then by being excited to these high temperature will eventually emit some light particles, and this is what we see with the light coming out. And the different colors is just basically it's different chemicals which lead to these different colors. And we know that when sort of the flame is slowly going off, um, we still have a little bit of red remaining. Okay, so we saw how burning can create light. And so there's a sort of a similar technique, which is, let's say, a little more modern, which is basically using these incandescent lights. And it's basically based on a very similar mechanism, except that what you're burning is just the filament, and it's not really burning because it's just heating up because you're putting it in vacuum or in an inert gas. And so we're going to look at the old-fashioned light bulbs. We're going to light this light bulb on, and then we're going to take it out, and you see it's going out. Okay, and then we're going to do some experiment with that. Cut. Bulb, and I'm going to try to make a hole at it. So I'm going to use this heater, and I'm going to punch a hole. Oof. Okay, cut. Here we can see the hole. So it really popped a nice hole inside. And so and it goes to the inside. That means that before it was basically vacuum, and now and that's why the glass which would melt it could pop into the inside. Now we're going to see what happens when we turn on the light again. This light bulb with this hole in there. Put it back in the in this thing, and you can see the hole. And now the question is, we're gonna turn it on and see what happens. And poof. Okay, so you saw that basically the light bulb it burned off the filament. Can one see the filament? And you see that the smoke is basically because it's burning off inside, and because there was no vacuum anymore, and that's why it basically burned off the filament. Okay. So here we can see the details of the inside of these incandescent light bulbs, where you see this nice scanning electron microscope image of the filament. It's a tungsten filament, so it's a very, very thin piece of wire where the current flows, and when the current flows through that wire, it heats the wire, and as long as it's in vacuum, it will not burn off. But as soon as you break the vacuum so that there's air inside, well, then nothing stops the filament from burning, and that's what we saw from when we turn on the light again. Is that basically that filament, because in the presence of air, will just start burn like anything would burn. So that's really the principle of these incandescent light, and it just the idea of heating up something, and by heating it up, you generate light because you're heating anything which is hot will create sort of a nice it will emit light, and the more you heat it, then the more sort of first gets white, but also it can get quite lit in the blue side. When it's very hot, it's more blue, and then if it's a little sort of colder, it's going to be more in the red light. Okay, so this is mainly the burning process. So we're going to look at a few other ones now. We're going to create light in a slightly more modern way. Here, so you see that this is the fluorescent tube, and what is actually happening when you turn on the light is that you're creating a huge voltage difference between these two sides, and that generates an electric field in the 10,000s of volts per meter, or even more, to transform the mercury which is inside to emit basically UV light. And this UV, which would be quite bad for us, is actually hitting the surface of the glass where there's fluorescence. So there's a fluorescent material there which basically transforms the UV light into white light, and that's basically what we see. And so let's now turn off the light, and you sometimes see an afterglow. Let's turn it on again. And so what it is the afterglow is this fluorescence which remains for a little while because of the UV hitting that surface. And it also takes a while to get on, is because you have to generate enough electric field inside the tube to generate this basically the UV emission of the mercury gas, and then which hits then the light. Okay, so that's the modern one of the modern ways to create light. So here we can see a little more detail the mechanism of this fluorescent light, which we saw the demonstration of. And again, the principle is really we have this huge electric field which rips off uh, the electrons from the mercury gas, and that creates that will create by recombining the electrons, they create this very high energy light, which is UV light. And when that UV light hits the surface of the glass, which has a phosphor coating, that will basically emit this white light which we see. And the spectrum it emits is shown on the bottom right, which is mostly visible light which is emitted. It has a lot of green in it, but it has a mixture also of blue and red, so overall it looks quite white. And it's quite different from the spectrum of old incandescent light, where you see there's much more red emitted there, and in particular there's a lot of infrared. And infrared is, if you just have infrared, it's basically just heat. You don't see it, but you feel it because it's really just hot. So that's why when you touch an incandescent light bulb, it's going to be very hot because of this infrared radiation. And that's what you want to avoid with these fluorescent lamps, which means that for the same power you put in, you're going to get much less heat, but much more light out of the lamp, and that's why they're much more efficient than these incandescent light. And so that's why they're used much more. But the next generation, and that's what we're going to talk about now, is the LED lamps. So what are LEDs and how do they actually emit light? Looking at an LED, so I have a yellow LED, I have a battery, and the two sides of the LED. So if I connect the positive side of the battery here and the negative side on this side, we'll see the LED actually lights. But what is interesting is if I reverse the polarity, if I put the negative side on this side and the positive on the other side, then nothing happens to LED. Do you see? So let me put it back so that I can get actually some light. And now the LED works. So the LED is very sensitive to the polarity of the current flowing through it. It will only light up if the current flows in one of the directions. So let's try to understand how an LED actually emits light. And the principle is actually quite different from the tungsten light or fluorescent light. So let me for that go outside and show you sort of a simple emission of a wave. Drop this. It makes a big noise. So what happened? So I I had this system which has a high potential energy, and when and that energy is basically transferred when it hits the ground. The potential energy of this thing is transferred into, actually some of it is transferred to sound, and that's what you're hearing. And that's basically because I'm generating another kind of wave from the energy I'm gaining by letting this fall down. So that's the very same principle as we'll see of how an LED lamp works. Okay, so the principle of how an LED works is actually not that different from what I showed outside. So except that object, instead of being, something big, is just going to be this tiny electron, which basically falls from a high energy state down to a low energy state. By doing that, so it basically falls from a high energy to low energy, and so it loses energy, and that energy it loses is going to be transferred into light, and that's the light we see. And the color of that light will depend actually a lot on how much from how high the electron falls. So if it just falls from, let's say, here to here, then it's going to be a red light, and if it falls from here to down here, it's going to be blue light. And originally people were only able to make red lights, but now we were able to do also green lights or blue lights, but they're typically more expensive. And the way you make an electron fall from up here to down here is by putting in some current. So you're forcing the electrons to actually fall off the cliff of an electronic structure. And these LEDs are usually made in silicon or some other type of semiconductor. Like in this case, it's the blue lights are made out of gallium nitride, which you've seen on the bottom. And that allows to generate sort of high energy light, which are and it took longer to actually come to this fabrication process of this. Okay, so that's basically how LEDs work, and let's have a look at the spectrum of this light. So now let's look at actually the color of the light, which is emitted by an LED. So you have on one side you have the blue, which is the high energy light, and then if you go, you have other LEDs which emit mostly in the green, and which is sort of slightly low energy, and then you have other ones which are going to be mostly red. But what especially in every case, it's a very narrow range of emission spectrum which is emitted in LED, and that's quite different from this other light bulbs, such as for example, what we saw at the beginning, which is the incandescent, which has a very broad spectrum of light emitted. Here, it's very narrow and very sharp, and that's really what makes LED quite special, because it's a very small window of light which is emitted. And that's because in that small window, it really depends on how much, on how high the electron falls to the low energy state, and then this change in energy basically defines what is the light color, essentially. A modern version of an LED light. This is sort of many of these small LEDs, and as we saw before, this is basically this gives just a small, not very much light. But if I turn on the big LED, the commercial one, you're going to see that the light is much stronger compared to the small LED ones.
Indeed.
And that's how modern LEDs work. They're just many of these small ones put together in order to create this very bright white LED light.
Cool. Wow.
Thank you.